Good morning, class. How are we doing today? This week, we are going to talk about multiplication of fractions. Now, again, we're gonna talk about the procedural knowledge and conceptual knowledge of a multiplication of fraction. Now, what is the procedural knowledge? Procedural knowledge is described as a mastery of computational skills and a knowledge of procedure in identifying mathematical components, algorithms, and definitions. So when we do the multiplication of a fraction, and you will do all the procedure, and then that is the procedural knowledge. And what about conceptual knowledge? Conceptual knowledge is described as the relationships and the interconnections of ideas that explain and give a meaning to the mathematical procedures. So the conceptual knowledge cover, basically just like you're gonna explain the meaning behind, okay? Now, here is a problem. We can take a look. There are 3 water bottles, and each bottle is 3/4 with a filled water. If we pour all the water together, how many water bottle can be filled to fill up? So you take 3 bottles, 3 water bottles, and each one is 3/4. So here is all 1/4, 2/4, and 3/4, right? So 3/4 and 1/3, 2/3, 3/4, right? So that's why we take a 3 times 3/4. So now you're gonna take procedurally. This is a procedural knowledge. Procedural knowledge. This is a conceptual knowledge. Now, procedurally, you would take 3/1 times 3/4, right? And therefore, you got 3 times 3, which is equal 9. So, did you see the 9 there? Yes, there's 9, right? 9 out of 4. 9 out of 4. So there's not 9 out of 4. So this is an improper fraction. And also we can change this into a mixed number. A mixed number, which is we can change this into 2 and 1/4. 2 and 1/4. Why it is 2 and 1/4? If you fill in all the water, see, is we got a 1 hole, and we got a 2 hole, and then what's left over? We got a 1/4, right? So therefore, you can see the picture here, okay? All right, so now let's move on to next problem. Tom has 5 acres of land, and he grows vegetable on 1/4 of it. Jerry has 4 acres, and 1/3 of it is planted with vegetables. Who has the biggest area of the vegetable? So we're gonna compare Tom's and Jerry. Okay, we gotta compare. So let's take a look at Tom. So 5 acres. So this is a 5 acres, right? But Tom only grow vegetable, how many? 1/4. So 1/4 of 5 acres, all right? So this is a 1/4, 2/4, 3/4, and 4/4, right? So we only take what? 1/4 of this. 1/4 of this. So 1/4 of this is what the Tom grow the vegetable. All right. So we take a procedurally, we take a 5 times 1/4, right? And we take a 5 times 1/4 procedurally, and we have a 5 out of 4. So did you see this is a 5? 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5, right? And then all of, we count in this one, you know, we count in 1, 2, 3, 4 as a one whole, right? So that's why we have 5/4, right? All right, so 5/4 for this. Now, we also can see, make a mixed number. Now, did you see, you know, we have make it as a mixed number. We have a one whole, this is a one whole, and this is a 1/4, right? And now, we also can change this into different common denominator, because later we're gonna compare, you know, Tom and Jerry. So we're gonna compare, right? So if this is make it into a 12, how many are there on the top? So how many on the top? So we have a 15 out of 12 on the top, and then 12 on the bottom. Okay, so that is the Tom's, you know. How about next? Jerry. So we're gonna do Jerry. Jerry is a 4 acre, has 4 acre, but he only, you know, plant 1/3, right? So where is the 1/3? Show 1/3. Did you see 1/3 there? Yes, this is a 1/3, right? So this segment, you can see this is a 1/3 out of 4 acre, right? Now again, we can change this into what? Procedurally, we take a 4 times 1/3. So therefore, we got a 4/3. This is a procedurally, right? And then conceptually, you can see 4, 1, 2, 3, 4. 4 out of how many? 4 out of 3, right? So therefore, we want to compare Tom and Jerry. Actually, we can still make it this in procedurally. Procedurally, we still can make it this as a mixed number, right? Right. And next, you can see 1 and 1/3, right? 1 and 1/3, and this will represent one whole. And what's left over? 1. So that, therefore, this is 1 out of 3, right? Now, next we want to compare Tom and Jerry. Now, if we compare Tom and Jerry, the common denominator is not same, it's not easy to compare, right? So therefore, what should we do? We can change this into a common denominator, right? So therefore, 4 and 3, the common denominator is 12, right? So it's 12, right? So once we change this into 12, and you can see the top would be 16, right? Top would be 16. So therefore, you can compare, this is a 15 out of 12 for Tom. This is a 16 out of 12 for Jerry. So which one has the biggest area of vegetable? You can compare, right? So therefore, we can say Jerry. Jerry has the biggest area of the vegetables, all right? Okay, now, Did you get it for this problem? Right? This is a procedurally. This is, and the picture I show to you is a conceptual understanding, okay? So in your homework, you need to show me what's the procedural and what is the conceptual, okay? All right, you have to explain, okay? You have to explain to me. All right, so now another problem. Tin's storage is 2.5 meters long and 3 meters wide. What is the area of the storage? So I'm going to show you 2.5 meters long. So this is 2.5 meters long, okay? 2.5 meters long, like this, okay? And then 3 meters wide, 3 meters wide. So 3 meters wide. So this is a 3 meters wide, right? So if we want to find what's the area, we can say 2.5 times 3, right? So this is a 2.5 meters long, and then times 3, all right? And then we can find the area, okay? So this is show you how the meter long, and then this will show you the meter wide, and we can find the area of this, right? So this is how many, right? We're finding out, okay? So again, here, procedurally, we change 2.5 into improper fraction of 5 or 5/2, and then times 3, okay? So therefore, you can see, you know, let's go back to here. This is 1/2, 2.5, the lengths are like this, right? This is all the lengths I use in one color. This is all lengths of 2.5, right? And then when we do the multiply, and then therefore we got the area, right? So multiply. All right, so now did you see 3? It's all 3 linear unit, right? 3 linear unit, right? So the overlap, this piece is the area. This is not area. This is not area, but the overlap, this piece is the area, okay? That's the concept of the area, okay? So 5/2 times 3/1, which is how many? Which is 15 out of 2, right? 15/2. So can you show me? Can you see the 15 out there? So that's the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15, right? 15. So 15, and you see this is to show you the 15. The 15 is the overlap. The overlap, okay? Now what about 2? What's the 2 mean? 2 means that we define under 1 by 1 this, right? How many of them? 1 and 2, right? So 2 consider as one whole, right? So therefore, you know, we have a 15 out of 2, all right? So we also can change this into a mixed number. A mixed number, you can see 2 unit consider as one whole. So how many whole we can find? we can find 1, 2, 3, 4, and 5, and 6, and 7, right? 7 hole. 7 hole, and what's left over? 1 out of 2, right? 1 out of 2. So this is show you the procedurally and then conceptually understanding for this, right? You want to take a look, one more time. You take, when you change it into, you take a 2 and 1/2 times 3, right? And then you're gonna change it into improper 5 over 2, right? And then you take a 3 times 5, you got 15. Did you see the 15 there? Yes. Did you see the 2 there? Yes. Did you see where is the 7 there? 7, which is 1, 2, 3, 4, 5, 6, 7. 7 there, right? And then did you see this is 1/2, right? Okay. So this is the meaning of area meaning, okay? Let's take a look at another problem. On Friday noon, John ate pizza for dinner. Had 1/2 of the pizza left over. One Friday night, he ate 1/3 of what was left. How much pizza did John eat on Friday night? All right. So I'm going to show you what's the 1/2. Okay, that's the 1/2. Make sense to you? All right. And he had the 1/2 of the pizza left over. So this is the pizza left over, right? It's pizza left over 1/2. Now on Friday night, he ate 1/3 of what was left. So actually, 1/3 of this much, right? 1/2. So therefore, that's why we take a 1/2 times 1/3. So 1/3 of 1/3 of 1/2. So that's why we have this. So we take a 1/2 times 1/3, which is how many? Which is 1/6, right? 1/6. So this unit actually is 1/6, right? And why it is 1/6? Because this is only 1 for here, right? On the top. And how many for the bottom? 6 is on the bottom, right? 6 is on the bottom because 1, 2, 3, 4, 5, and 6. 1 hole, we have a 6 unit, right? Okay. Now next problem 5. Jocelyn lemon cookie recipe calls for 1/3 of a cup of sugar. How much sugar would Jocelyn use to make 1/2 a batch of cookies? So 1/3, right? 1/3 of a cup of sugar, like this. Makes sense. 1/3 of cup of sugar, yes. Now, how much sugar would Jocelyn use to make 1/2 a batch? So you want to take a 1/2 of 1/3. So you take a 1/3 times 1/2. So therefore, you got this much. So therefore, you take a procedurally, you take a numerator times the numerator, denominator times the denominator. So you got a 6, right? So you will get a 6. So what's the 6 mean? See, this is a 1 hole. Now 1 hole, we have how many units? 1, 2, 3, 4, 5, and 6, right? And then we have how many of them? For this, we have 1. So therefore, is 1 out of 6, right? So the answer is 1/6. Next problem, Tim's poster is 1/2 wide and 2/3 feet long. And what is the area of a poster, right? So this is 1/2 We take a 1/2 times 1/3, right? So this shows you 1/2, makes sense. This shows you 2/3, makes sense. All right, good. Now we're gonna move on to this. You take a 1, procedurally, you take a 1 times 2 and over 2 times 3, right? 1 times 2, 2 times 3, like this. So this is 1/2, this is a 2/3, right? And then area times together will be this area, right? So therefore, you will get how many? You take a numerator times the numerator over denominator times the denominator. So you got a 2/6, right? 2/6. 2/6. So what's the 2 here? Did you see 2? Because overlap is 2, 1 and 2. Right? Now what about 6? What's the 6 mean? Under 1 by 1, how many units? We can count as one whole. We have 1, 2, 3, 4, and 5, and 6 like this. So under 1 by 1, 1 by 1 unit is one whole. Because 1 by 1 is equal 1 whole, right? So therefore, we have a 6. So did you see 6? This is a denominator, all right? And then numerator is overlap. Numerator is overlap, like this, all right? And denominator is counted under 1 by 1 is equal how many? How many are there? How many under 1 by 1? We have 6, all right? 6 boxes, right? Okay. And then, can we also change this into reduced by fraction? And then this is 2/6, which is equal 1/3, right? Okay. So the answer is 1/3. Oh, go back. The answer is 1/3. Actually, don't forget about, okay, full square, okay? Now next problem. Now Lisa used 3½ cup of vinegar in her salad dressing recipe. And how much vinegar would Lisa use to make a 1/3 recipe? So I'm gonna show you. This is a 3½ That makes sense to you? Okay. Now, I'm gonna change this into what? I'm gonna change this into improper fraction. So we can take, for procedurally, you wanna change this into improper fraction, which is 7/2, right? 7/2. So 7½ like this. Did you see 7½ there? Yes, visually, okay? Now, 7½ times 1/3, right? And 7½ times 1/3 actually is 7½ divided by 3, right? Divided by 3. Did you get it? Times 1/3, which is meaning is divided by 3, right? So divided by 3, look, we have this unit, this unit, this unit, this unit, right? And then this unit, this box. And then we all, see, divided by 3. See, the blue one is the whole, and we divided by 3, we got this much, right? And then same as here, we got the divided by 3, got this much. Divided by 3, got this much. Divided by 3, 1/3, divided by 3, we got this much, right? So altogether is equal how many? Oh, altogether is 1, 2, 3, 4, 5, and 6, and 7. So that's why we got a 7/6. That's why we got a 7/6. right? We got a 7 over 6. Now 7 over 6, which is when we change it into mixed number. All right, 7 over 6, okay, and that's one whole, right? 2, 3, 4, 5, and 6 is one whole. And then what's left over? We have 1 left over. So therefore, 1 and 1, 6. So we can change this into the mixed number as 1 and 1, 6. Did you see it? 1 there. Where's 1? This is 1, right? Did you see it's 1, 6 there? This is 1, 6. Because this is not 1. This is 1 out of 6. All right. Okay. Now what about now I want to give you a couple minutes to take a look for this problem again. Okay. You take a 3 and 1/2 times 3 and 1/2 times 1/3. All right. And what did you see? You know, what did you get it? You know, procedurally and conceptually. Procedurally, you know, can show you the segment. All right. Now, next problem is another mixed number multiplication. Now, King's poster is 1 and 1/2 feet wide and 2 and 2/3 feet long. And what is the area of the poster? Now, again, this shows you 1 and 1/2, right? And then we're gonna times 2 and 2/3 times 2 and 2/3. 1 and 1/2 times 2 and 2/3 right here. All right. So this area is our answer, right? 1 and 1/2 times 2 and 2/3. This is our area, right? Okay. Now next, gonna change this into improper, which is a 3/2. All right. 1/2, 2 over 2, 3/2, right? So that's the 3/2. And then next, we're gonna change this into improper fraction. This is 8 out of 3, right? This is 8 out of 3, right? 8 out of 3. So did you see the procedurally with just 3/2 and then times this is change this into a 3/2. This is what 8 out of 3, right? So 8 over 3, right? So therefore, we have how many boxes there? 1, 2, 3, 4, 5, 6, 7, and 9, 11, 12, 13, 14, 16, 17, 18, 19, 20, 21, 22, 23, 24. All right, and then this is 3 over 2. This is 8 over 3. Now 3 times A, which is how many? 28, 24, 24. Did you see 24 there? Visually, yes. Now what about 6? What's the 6 meaning? 6, remember that we on the 1 by 1, we have how many boxes counting as a whole? We have 1, 2, 3, 4, 5, 6. We have 6 boxes there as a whole, right? So therefore, 24 out of 6 actually is what? How many whole? How many whole? 1. So we have 1 whole, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2 whole, 1, 2, 3, 4, 5, 6. 3 whole, and 1, 2, 3, 4, 5, 6. We have a 4 whole, right? So therefore, the answer is equal 4 square foot. right? I want to give you a couple minutes to take a look at procedurally and conceptually for this problem, all right? Did you get it? Well, if you have any questions for the problems, I present to you, just email us, email me, and then I will help you to have a better understanding for this, okay? Well, thanks for watching, and you have a great day. Thank you.